Good morning, this is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, today we will continue on reliability of bivariate econometric modeling. So, today's our main agenda is to take a problem and highlight the details about this reliability part. So, that means we have to see how this econometric modeling, bivariate econometric modeling can be fitted and how we have to go for this reliability check. So, before I start with this particular solutions, so let me briefly highlight once again this reliability part of this bivariate econometric modeling. So, now for bivariate econometric modeling, so we know the system must be with respect to two variables, say y and x, and for this we have fitted a regression equations y hat equal to alpha hat plus beta hat x. Okay. So, this is our estimated models which we have received through the through the help of certain information. So, we must have information on y and x, and by the process or some applications. So, we have received this y hat equal to alpha hat plus beta hat x. So, now our agenda is here. So, the moment you get the estimated model, it should be perfectly okay. So, that means otherwise it is called as a best fitted models. So, now this to get this best fitted models or to know whether this model is the best fitted one. So, we have to go for this reliability of estimated model. So, reliability of econometric model or estimated model has two parts, that is with respect to estimated parameters, okay, and basically here alpha hat and beta hat, and second part is the overall fitness of the models, overall fitness of the models, and that is nothing but R squares. Okay. So, this has to be investigated by T statistic and this is investigated by F statistics. This is how we have already discussed. Let me highlight how the structure of this first part, that is the reliability of parameters. Okay. So, for this we have to prepare a tables here. So, reliability of estimated parameters. So, the problem is like this. So, you have estimated parameters. So, then estimated value, okay. Then variance of estimated parameters, then standard error of estimated parameters, then T of estimated parameters, then level of significance. This is how we have to, you can say, sorry, estimated value, variance of a standard error, T, and like this. Okay. So, in fact, this is estimated parameters value. Okay, we will put it like this: estimated parameters here, then this is value of estimated parameters, then this is variance of estimated parameters. Okay. So, now for this you have alpha hats and you have beta hats, all right. So, you have alpha parameters and beta parameters. So, the estimated value equal to y bar minus beta hat x bar, and this is summation x y summation x squares. Okay. So, this is variance, means it is sigma square u summation x square by n summation small x square, and this is sigma square u by summation x squares. Okay. So, now this is variance of alpha hat and this is variance of beta hat to the power 1 by 2, and this is alpha hat by standard error of alpha hat, and this is beta hat by standard error of beta hat. Okay. This is how we have receipts. Okay. So, the probability level of significance we have to judge accordingly. So, now the second part of the model is the ANOVA, that is analysis of variance. ANOVA, this is first part and this is second part. So, this second part is there are certain structure here, there are sources of variations. sources of variation. So, the sources of variations are explained sum square, then and then residual sum squares, and then total sum squares. Okay, this is total sum squares. So, now sum of squares, So, sum of squares here summation y hat square, this is a summation e squares, and this is summation y squares. Okay. So, mean sum squares. So, mean sum square is nothing but summation y hat square by k minus 1, then this is summation e square by n minus k, and this is summation y square by n minus 1. Okay. And next is the degrees of freedom, then f statistics and probability level of significance. Okay. Degree of freedom here k minus 1, this is n minus k, this is n minus 1. So, f is nothing but ESS by RSS. So, that is nothing but summation y hat square by summation e squares. Okay. So, p will be defined accordingly. So, now you see here the fundamental principle is here. So, we like to know what is R squares. So, which is nothing but ESS by TSS. Okay. So, in other words, it is nothing but summation y hat square by summation y square. So, it is nothing but summation x y whole square by summation x square into summation y square, because y hat equal to beta summation y hat square equal to beta hat summation beta hat and x. Okay. So, summation beta hat x. So, this is how we have received this particular items. So, now here summation y square equal to summation y hat square plus summation a squares. Okay. So, this is the TSS, this is ESS, this is RSS, total sum square, explained sum square, residual sum square. Okay. So, now sigma square equal to summation e square by n minus 2. Okay. So, now there is a corresponding to R, we have another reliability factors called as a adjusted R square. This is what we call it adjusted R square. So, adjusted R square is nothing but 1 minus R square into n minus 1 divided by n minus k. Okay, n minus 1 into n minus k. So, this particular item is very relevant when we will go for multivariate models. So, but the for this time being still it is very important, because it adjusts the degrees of freedom. So, now for a particular discussion. So, what we have to do? So, we have to solve a particular problem with regards to this particular structures. So, let me highlight here. So, we will put it here some items. Let I will call it here x, and this side I will call it y. Okay. So, let it be, first we enter this data. So, this is 51, then 60, then 65, and this is 71, then this is 39, then 32, then 81, then 76, then 66. Okay. 51, 60. Okay. This is 60, then 65, then 71, then 39, 39, then we have to cut it here, paste. Okay. So, this is x series, and corresponding x series y have 187, then 210, then 137, then 136, then 241, then 262, then 110, then 143, then 152. Okay. So, there are we have taken altogether 9 observations. Okay, view, let me highlight a little bit here. So, view, zoom, put it at 200. Okay. So, now so this is how we have received the entire structure here. So, the series is x y this is what okay, all right. So, now this is x series and this is y series, there are 9 observations. Okay. So, how do you proceed for this particular structure? So, now the model is with respect to y and x. So, we assume that the regression model equal to y equal to alpha plus beta x plus u, and through which by the process of OLS applications we have received y hat equal to alpha hat plus beta hat x, and where alpha hat equal to y bar minus beta hat x bar and beta hat equal to summation x y by summation x squares. All right. So, now after getting this much information, we have to go for reliability test. That means, we have to judge whether this particular model is the best fitted one. So, now for this we have stepwise procedures. So, we have to proceed step by step. So, this is step 1. So, how do we go for this means here our agenda is to check whether this particular estimator is best fitted or not. So, for that we have to proceed in a stepwise process. So, now first step is to know the descriptive statistic. Okay. Descriptive first you have to know the descriptive statistic. Okay. Descriptive statistic. So, the descriptive statistic basically deals with x bar and y bars. Okay. So, x bar y bars, sigma x, sigma y, then this is you can say variance covariance matrix. Then we have to know variance covariance matrix, sigma 1 1, then sigma 1 2, sigma 2 1, sigma 2 2. Okay. So, then of course, we like to know maximum of the series, we like to know the minimum of the series, then we like to know the median of this series. So, many things we like to know. Okay. So, now you check it here. So, this particular items if you take, so we have to fill up this particular gap here. So, this is equal to, so in fact, here there is a lots of application. So, we like to know not some. Okay. And this is sum. Okay. So, first is summation x equal to 541. All right, 541. So, then okay, 1578. So, summation y equal to 1578. Okay. So, to know maximum and minimum, so you can put it here in a ascending order or descending order. So, you can get to know very easily. So, you put it here ascending to descending order. So, you get to know. So, now that means for x the maximum is 81, this is for x, and the minimum is 32. Okay. So, this is 32 for y. Okay. So, similarly, in this series you can also arrange in ascending order. So, this is how you will get it. 262 is the y series, this is y series. Okay. So, this is x. Okay. And minimum is here 110, this is for y. Okay. So, this is very means this much of information is required, because we like to know what is the variation inside the particular game boundary. So, if you know in details, then obviously the model can be much more, you can say feasibility, or you can say reliability. So, anyway, you have to now you have to go back to the original position where we have started. So, this is how the observation. So, how do you proceed? So, this step 1 information is just to know the descriptive nature of the statistics. So, because I have not highlighted details here x bar and y bar. So, that means here n equal to 9. So, you divide by n. So, you will get x bar, and you divide by again 9 here. So, you will get y bar. So, similarly, you will get sigma x and sigma y. So, that is sigma x means x minus x bar. So, we have to create a series x minus x bar, and we have to create again a series y minus y bar. So then you have to create a series summation x minus x bar into summation y minus y bar. So accordingly you will get several items, so that it can be explained the variance covariance matrix. Because here our main agenda is not to describe this entire situation, because it is it is relevant, but in the meantime we are skipping all these details, because our main agenda is to check the reliability of the model. So what we have to do in the step 2, you have to get the first alpha head component, and we have to get the beta head component. Okay. So alpha head equal to y bar minus beta head x bar, and beta head equal to n summation x y minus summation x into summation y, then n summation x square minus sum x whole square. So now, so what is our requirement? So what we quickly calculate the we need to calculate summation x equal to some how much summation y and summation x y. Okay. So then we have to know summation x squares, and we like to know again summation y squares. Then you like to know okay, in the meantime this is summation x square, and we like to know summation y square value, and this is n value, n equal to 9 here. So summation x equal to here 541, then summation y is here 1578, then summation x y. So what we have to do? We have to calculate a series here. So which is x y. Okay, x y. So now this is nothing but equal this multiplied by this. Okay. So now we will get it this 9537. So you just scroll it. So you will fill this particular columns. So this enters. So now we like to know what is the sum of this particular series. Okay. So this is enters. So the sum is x 88291. Okay, 88291, and the summation this is 88291, 88291. Similarly, we like to know summation x square. So what you have to do? This is x x, and another column we will calculate y y. Okay. So now this is equal to 51 again multiplied by these same items. Okay. So then you scroll this series, particular series, then you will get it here, the entire items. Okay. So now again this should be copy, this should be copy. Okay. Then enters. All right. So now here y y we have to fill this series, y multiplied again y. So we need to know the summation y square. Okay. So again you have to scroll these items. So this item. Okay. So now what we have received? So now this is summation y square, that means summation y square is equal to 298,712, then summation x square is equal to 34705. Okay. So n is already here. Now you come to the pictures. So what we have to do? We start with the beta head first, then we will get it alpha head. So beta head equal to n summation x y. So that means n equal to 9 here. So 9 into summation x y is 88291. Okay, minus summation x into summation y. So this is 541 multiplied by 178. Okay. So divide by n summation x square. So this is 9 into summation x square equal to 34705. Okay, minus sum x whole square. Sum x equal to 541. Okay. So this is whole square. So we like to know what is this exactly value. So what we have to do here? So this is nothing but we like to know 9. This is equal to 9. Okay, you will put it like this. So 9 into 88291, 88291. So this is okay, minus then 541. Okay, what do you have to do? $541. Okay, and okay, 541 multiplied by 1578. Okay, so this is how you have received. So Okay, so denominator is like this. So 9 into, okay, once again we will check it. So 9 into 88291, then minus 541 into 1578. Okay, so this is coming minus 59079. Okay, so this is equal to minus 59079. Okay, so divide by another items we will create. So which is equal to minus and 9 into 34705 okay, minus minus 541 into 541. Okay, this is okay now 34705. Okay, so this is enters. Okay, so this is how 19664. So now what you have to do? So we have to find out to equal to this divided by this particular items. Okay, so now this is, so if you will solve this one, then it is coming minus 3.004. Okay, so this is how beta hat. So that means beta hat component is a minus 3.004. So beta hat is, this is negatively sloped. So that means this relationship is inversely related to each other. So y and x are inversely related to each other. So corresponding to beta heads, so we like to know what is alpha head here. So a beta head, okay, I am repeating here once again. So beta head is coming minus 3.004, and we like to know what is alpha head. Alpha head equal to y bar minus beta head x bar. So that means what is y bar here? Now 1578 divided by 9 minus beta head equal to minus 3.004 multiplied by x bar. X bar is 541 divided by 9. Okay, so which is equal to, so okay, what we will do here? So this is equal to 1578 divided by 9. So we will get 175.3. Okay, so then we like to know 541 by 9. Okay, so this is 541 divided by 9. So you will get 60. Okay, so that means this is 175.33. Okay, minus what you will do, this is minus 60. So this is minus and this is minus, this is minus and minus plus. So what you have to do, so this is minus equal to minus 3.004 multiplied by this particular item. Okay, so this is coming 180. Okay, so now 170, this is equal to 175 minus this particular item. So it is 355.907. So it is coming, so minus into minus 80.574. So this will be coming 355.907. So this is how y bar means alpha hat equal to y bar minus beta hat x bar. So y bar equal to 175.33 and x bar equal to 180.574. So obviously if you will simplify, then you will get it the term 355.907. So the estimated equation equal to minus 3.004 plus 355, sorry, okay, this is not correct. So y hat equal to 355.91 minus 3.004 x. So this is what the estimated line. So this is how the estimated line. So what you have to do? So we will go to this particular, we copy these items, then you go to next sheet and again you paste it here. Okay. So now go to view, zoom, sec 200. Okay, all right. So now, so we have x series, we have y series. So we have to create here y head. Okay. So y head. Okay. So we will create y head. What is y head here? So, y hat equal to 355.91 minus 3.00 x. Okay. So, this is equal to 355.91 okay, minus 3.00 3.004 okay, multiplied by y hat equal to into x. Okay. So, this is what we have received. Okay. So, now you just scroll it. Okay. So, this is what the y hat series, So, corresponding y hat we have to get E hat error component. So, E equal to y minus y hat. So, this is equal to y minus y hat. Okay. So, this is what we have received. Okay. So, now just you scroll it. So, this is how you just check it what is the error sum. Okay. So, this error sum is it should be coming around close to 0. Okay. This is okay. So, now what we have received. So, initially we started with the you can say y information, x information. In the meantime, we have received y hat and we have received the error component. So, now what you have to do means how you have to proceed further. So, now we have received this y hat component. So, this y hat component. So, this is y hat equal to 355.91 minus 3.00 for x. Okay. So, now we have this is how y hat we have received. So, now y hat is this much. So, what we have to do? So, this is otherwise known as. So, in other words, this is y hat equal to alpha hat plus beta hat x. Okay. So, that means alpha hat is this much and beta hat is this much. So, now we like to know the reliability part of the model. So, that means we like to know whether this alpha hat is statistically significant or beta hat is statistically significant. So, now for this we have to proceed further to calculate the variance of alpha hat and variance of beta hats. Okay. So, now let me highlight here. So, you know variance of alpha hat equal to sigma square summation x square by summation x square. All right. So, now n summation x square, this is n summation x square. So, now what we have to do here is you first calculate this sigma square is summation e square by n minus 2. Okay. So, what is summation e square? Summation e square equal to summation y square minus summation y hat square. So, summation y hat square. So, now basically here summation y square means summation y minus y bar whole squares. Okay. So, similarly, summation y hat square is nothing but summation y hat minus y hat bar whole square. Okay. So, obviously, summation a square we will get it accordingly. So, now we have to calculate summation y square first. Okay. So, how do you go for that? So, we will create here. We first like to know what is the mean of this particular series. Okay. So, mean of this particular series you can get it here. So, this is what the mean. So, 60.11. So, is it okay? 60.11 mean of this series. Okay, 60.11. So, this is how we have to received. Okay, 75.33. All right. So, this is mean of x, this is mean of y, this is mean of y hat. So, we like to know summation y squares. Okay, summation y square. So, y minus y bars. Okay. So, this is how we have to make it squares. So, all right. So, this is equal to y minus y bar. So, this minus 175.34. So, 175.34. So, right, 175.34. So, this is what we have received. Okay, y minus y hat. So, this is copy. Okay. Now, it is all right. So, this is we have to make it square again. So, okay. So, this is what we have to do multiplied by these ones. Okay. So, this is 1356. So, we can okay. So, Alright. So, now this is y hat square. So, this particular this is y okay, no, this is y square. Okay. So, summation y square equal to, so 22036 22036 summation y minus y hat square equal to 22036, and obviously it is divided by n. N is you can say by this is divided by 9. Okay. So, 2448. So, this is 2236 divided by 9. So, we will get, because this is summation y square means, so it has to be divided by n. So, it will be coming 2448.4. all right. So, similarly, summation y hat square. So, what we have to do, instead of writing y hat here, so similarly we have to create another series here, y hat square. What will we do, summation okay. So, similarly we have to find out here y hat squares. So, this is this minus 75.36. So, it will be coming like this. Okay. So, scroll it. All right. So, now you just go through. All right. So, this multiplied by this particular item again. So, this is coming like this. Okay. So, now this summation y hat square, so is equal to 28451.2. Okay. So, this is 2448.4. So, obviously, summation y hat square equal to summation y square. So, 244.8.4 minus 28451.2. So, this is somewhat summation y squares. Okay. Summation y square divided by n, 2236. So, this is y hat square 244822. This is 19, this is 9. Okay. So, this is how you have to receive this summation y square. So, 2448. So, this is coming equal to this minus this. So, this is 26002.8. all right. So, now this is how you have to fill this area here. So, variance of alpha hat accordingly you have to calculate. So, variance of alpha hat equal to sigma square. So, sigma square into summation x square by n summation x square. So, now here, so summation e square by n minus 2. So, that means summation sigma square equal to summation e square 92 means 26002 divided by n minus 2, this is 7. Okay. So, this is equal to divide, no sorry, okay. So, this is equal to 3715.7. So, this is sigma square u. Okay. So, now variance of alpha hat equal to sigma square u. So, 3715.7 into summation x square. So, summation x square we have received already here. Summation x square equal to, this is 347. So, this is into 34705 divided by n summation x square into 9. Okay. So, what we have to do actually, so we like to calculate first summation x square. Okay. So, we like to calculate summation y square, then summation x y. So, there is a standard formula before means unnecessarily we are wasting time. So, what we have to do here, so this is nothing but summation x minus x bar whole square. So, this if we will simplify further this particular extension. So, this is nothing but summation x square plus x bar square minus 2 into x bars. Okay. So, if you calculate further, then this is summation x square plus n x bar squares minus x bar into 2 summation x. Okay. So, now 2 summation x. So, this is summation x square plus n x bar squares minus x bar into 2 into summation x divided by n into n. So, this is nothing but x bar. So, summation x square plus n x bar squares minus x bar, this is x bar means 2 n x bar squares. Okay. So, this is n x bar square, this is n bar. So, this is summation x bar squares minus n x bar squares. So, this is what the summation x square value. Okay. So, accordingly we have to transfer all these things. So, that means we have information summation y square, summation y square, summation x y, then we need to calculate summation x square, we need to calculate summation y square, we need to calculate summation x y. These are very essential to, you can say, to consume less times. So, this is summation x square is in capital format and these are all small format. Summation x square is something summation x square minus n x bar square, then similarly this is summation y square minus n y bar squares. So, this is how summation x y minus n into x bar and y bars. Okay. Summation x y minus n x bar into y bar. So, now to get summation x square, we have summation x square. So, we have summation x square, that is 34705 minus n x bar square. So, minus n is 9 into what is x bar equal to simply what is x bar. Okay. This particular item, instead of putting sum, we will take average directly. Okay. So, now minus x bar square. So, this is nothing but x into 60.11 whole squares. All right. So, if you will simplify, you will get this summation x square value. So, similarly, summation y square equal to summation y bar square. So, this is summation y bar square. Okay. This is 298712 minus 9 into this is y bar square. So, 175.33 whole square. So, this is how summation y square we will get it. So, summation x square, summation y square. Similarly, with the help of summation x square and summation y square, we can able to get means we can able to calculate the summation y hat square also. Okay. So, now so the detailed structure is like this. So, okay, and this is equal to 34705 minus 9 into 60.11 into 60.11 to 186. So, this will be coming to 186.1 to 186.1. So, this is what we have received the summation 186 to 186.1. Okay. This is summation y square. Then similarly, y bar square equal to, this is nothing but 298,712 minus 9 into 175.33 multiplied by 175.33. Okay. So, we will get 220,220,220,46. Okay, 22046. Okay. So, this is how we have to receive the you can say summation y square, So, this is summation x square, this is summation y square. Then with the help of this we can also get to know y hat square. Okay. Summation y hat square is nothing but summation beta hat x whole square. Okay. So, that means it is beta hat square summation x square. So, what is beta hat square? So, beta hat square is nothing but summation x y whole square divided by summation x square into squares. Okay. Summation x square into x square. So, altogether this is summation y hat square, okay, beta hat square summation x square. So, summation into summation x square. So, this will be coming summation x y by summation x square simply. This is summation x y whole square by summation x square. So, this is what the beta hat square or summation y hat square. So, we like to know what is summation x y and we like to know summation x square, because summation x square is already calculated here. So, we like to know what is summation x y. Okay. So, summation x y is nothing but summation x y minus n x bar into y bars. Okay. So, what is summation x y here? Summation x y is here 888291 minus n into 9 into x bar is 60.11 multiplied by and then 175.33. So, which is the okay. So, this is equal to 88291 minus, so minus 9 into 6.11 multiplied by 175.33. Okay. So, this is coming negative, this is coming negative, and this is coming negative. Okay. So, minus 6560.8. One thing you must be very careful. So, actually we need to know the summation small x square, we need to know summation small y square, we need to summation small x into summation small y. So, you must be very careful that this must be always positive and this must be always positive. This can be positive, this can be negative, because this particular item is nothing but the covariance item and this is variance item, this is variance item. So, variance cannot be negative, means variance of x cannot be negative, variance of y cannot be negative. So, whatever formula you have to use, so it should be always positive. Okay. So, that is how summation small x square is always positive, summation small y square is also always positive, but summation x y can be positive, can be negative. If they are negatively related to each other, that means if x and y are negatively related to each other, then obviously summation small x y will be negative. If they are positively related, then summation x y equal to positive. So, that will decide whether this coefficient will be negative or positive, because it will indicate the negative association and positive association between these two variables. So, now the moment you get summation x square, summation y square and summation x y, then with the help of all these three items we can able to get the summation y hat square also. So, summation y hat square is equal to summation x y whole square divided by summation x square. So, this is 6560. So, what you have to do? So, you make it again square multiplied by this particular item. Okay. So, this is how it is coming like this. So, now divide by summation x square. What is summation x square? So, now so this is 430,43791 divided by summation x square. Summation x square is nothing but 2186. Okay. So, 2186 means we need to divide this divided by 2186.1. So, okay. So, this will be coming summation y hat square is coming 19689.76 19689.76. Okay. So, this is y hat square. So, now our standard structure is almost all okay. So, what you have to do? You go to this particular tables here. So, now you see we get to know this y hat, we get to know this beta hat. So, then we are in the process of calculating variance of alpha hat and we are in the process of calculating this sigma square u by summation x square. So, now once you get this all these details, once you get all these details, so what you have to do? So, we have summation x square, we have summation y square, we have summation x y, we have summation y hat square. So, now we need to calculate summation e square, summation e square equal to summation y square minus summation y hat square. Okay. So, the moment you will get all these things, then you have to go for variance of alpha hat. So, variance of alpha hat, in fact, once you will get summation e square. So, you can also in the same times you can calculate summation e square by n minus 2, which is nothing but sigma square u. Okay. So, now variance of alpha hat equal to sigma square u, then this is summation x square by n summation x square. So, sigma square you have to put it here. So, then you have to calculate the variance of alpha hat. Then standard error of alpha hat is equal to simply square root of variance of alpha hat. So, similarly, we have to calculate the variance of beta hat. So, variance of beta hat here, variance of beta hat equal to sigma square u divided by summation x square. So, now standard error of beta hat equal to sigma variance of beta hat. Okay. So, now once you get standard error of alpha hat and standard error of beta hat, then next procedure is to get the t statistics. Okay. So, before you move to t statistic, there is a need to set the hypothesis. Okay. There is a need to set the hypothesis. What is this hypothesis? There are two hypotheses actually. One is called as a null hypothesis and second one is called as a alternative hypothesis. Okay. Alternative hypothesis. First of all, what is hypothesis? Hypothesis means it is a statement which is not verified, we like to verify it. That means, here our observation is that alpha hat and beta hat has to be significant, and we have to verify that whether this alpha hat is significant or not significant. Similarly, beta hat is significant or not significant. So, we have to set the hypothesis. That means, how we can justify that whether it is significant or not significant. So, that means, alpha hat must have some value and beta hat must have some value. So, the moment you have a value, then accordingly you can go for the statistical test. That means, in the standard rules which we have discussed in the last class, that we need to calculate the t statistic and you have to compare with the tabulated statistics. So, that means, if you have some value, then you can calculate the statistic and you can compare with the tabulated. If there is no value, it is very difficult to calculate. So, what you have to do? So, in this particular context, so null hypothesis means a hypothesis which you have to set to verify or to to verify a particular objective, which then generally we set null hypothesis negatively. That means, for this this particular problem, so we said that for alpha hat equal to 0. So, we start with negative assumption. So, that we have to our objective is you have to reject that assumption. So, h 0 equal to alpha h 0 such that alpha hat equal to 0 against h a such that alpha hat not equal to 0. Similarly, for beta, h 0 such that beta hat equal to 0 and against alternative hypothesis beta hat not equal to 0. So, that means, we start with the standard assumption that alpha hat equal to 0. So, that means, there is no value at all. So, we have to justify that alpha had some value. So, the moment you will get alpha had some value, then automatically the null hypothesis will be rejected. So, our every time objective is to reject the null hypothesis. Null hypothesis means the statement we start with a negative direction. So, then we have to reject that negative direction, then come to the perfect means perfect accuracy, that is the significance level of the test. So, what is all about this particular assumption? So, the standard rule is that we have to calculate this t statistics. So, now t alpha hat equal to alpha hat by standard error of alpha hat and t beta hat is equal to beta hat by standard error of beta hat. Okay. So, now this is calculated statistics we have to derive, then we have to compare with the tabulated statistics. So, what is the structures? Actually it is structured by this means it is purely followed by the normal distributions. Okay. So, now the hypothetical means testing of hypothesis based on this particular structures. So, this is how we will classify the entire diagram into 3 parts. This is one part, this is another part, and this is another. This is the mean of this particular series. Okay. So, now what you have to do, this particular region is called as a accepted region. So, this particular region is called as a accepted region. So, this particular area is called as a rejected region, So, this is also a rejected region. So, now let us start with some value. Let us say there are t has a certain value with respect to the different sample size and degrees of freedom. So, let us assume that when you will go for hypothesis testing, there is a 2 different setup. It is called as a one tail test and two tail test. So, one tail test means this is remaining closed and this will be expand. Okay. So, this means this particular structure is called as a right tail test, and if you will close this one and you will expand this one, it is called as a left tail test. So, now what you have to do, if you will divide equally, then there is called as a two tail test. So, that means 50% this side and 50% this side. So, now let us assume that there is a certain value set to this side, everything will be positive. So, the t value is 1.2. Okay. So, this side minus 2.12. So, now with the basis of some value alpha hat, how what is the alpha hat, and we have also calculated standard error of alpha hat. So, now the ratio between alpha hat and standard error of alpha hat will give you the t of alpha hat. So, now we have to position the t of alpha hat, that is the calculated. This is what the tabulated statistic all about at a certain degrees of freedom, or you can say sample size. So, now let us assume that for the particular problem the t value, tabulated t value is 2.12 for right tail and minus 2.12 for the left tail. So, now we have to see what is the t alpha hat, that is calculated statistic. So, now the moment you will get t alpha hat, the calculated statistics, then you have to represent, you have to just check it whether it is negative or positive. If it is negative, then the structure will be coming this side. If it is positive, then the structure will be coming this side. So, now let us assume that this particular item say minus 3.23. So, that means this particular item is coming this side. So, that means it is nowhere in this particular region. So, now if this is the structure, then the structure is minus 3.23 is greater than to minus 2.12. Okay. So, means it is not a greater than, obviously it is a less than. So, that means it is coming this side. So, this side coming means we are rejecting the null hypothesis. So, the moment you are rejecting the null hypothesis, that means alpha hat is statistically significant. Similarly, suppose we will get the component called as a 3.23 positive. So, 3.23 means this particular value will be coming this side. So, that means it is greater than to this item. So, that means it is in the rejected region. So, the moment it will be in the rejected region, so that means we are rejecting the null hypothesis. The moment you are rejecting the null hypothesis, so the observation is that, or we have to represent that this particular item is statistically significant. So, now you take in otherwise. So, this is 2.18. So, I will take I will get the t statistic alpha hat is equal to simply 1.21. So, now 1.21. So, this is 0.0 origins. So, 1.21 means this will be coming in this particular range. This is 2.12. So, this will be coming this range. So, obviously, this particular means this particular value will be placed in this region. This is accepted region. That means we are accepting the null hypothesis. The moment you are accepting the null hypothesis, that means by default we will call it as a this particular parameter is not statistically significant. Okay. So, similarly, let us assume that we are getting t alpha hat or t beta hat equal to minus 1. You can say 61. Okay. So, minus 1.61. So, minus 1.61 means it will come left side, and here the bound means boundary is minus 2.12. So, that means it will not cross this one. So, minus 1.61 means it will be placed somewhere here only. So, that means it is still in accepted region. So, the moment it will be in accepted region, so we are rejecting the means sorry, we are accepting the null hypothesis. The moment you are accepting the null hypothesis, so that means our observation is that we are rejecting the, means we are in the position to say that this particular statistic is not significant. So, that means what is this? We have two steps here. First step is you get the calculated statistics for alpha hat and beta hat, and again you have to know the alpha hat the tabulated statistic and beta hat tabulated statistics. Then you fix the range, then you just check whether the calculated statistic means what is the position of calculated statistic. If it is coming this side negative and this side after the del line, then we have to reject the null hypothesis and put the statement that it is significant. Similarly, this side if it is positive and if you are going beyond that one, then we are rejecting null hypothesis and putting the statement that it is statistically significant. Otherwise, the conclusion is that the parameter is not statistically significant. So, this is how we have to justify the hypothesis testing. Of course, we have not considered here the level of significance. This is based on two things. First is with respect to number of sample size, that to degrees of freedom, and second thing is the probability level of significance. It may be 1%, it may be 5%, it may be 10%. The values are coming different with respect to 1%, 5% and 10% corresponding to different levels of probability, and the sample size, the items will be different. So, you have to compare with it a calculated statistic with the different levels of you can say probability level of significance. Accordingly, you make a judgment. Okay. So, whether it is statistical significant at 1% or statistical significant at 5% or statistical significant at 10%. If not, then you will simply that the statistic or the parameter is not statistically significant. With this, we will conclude this session. In next class, we will go in details about this ANOVA part, how you have to proceed with the ANOVA, and you have to justify the significance of the particularly overall fitness of the model, that to R square. Thank you very much. Have a nice day.